Good morning, everybody. I'm Chrystian Vieyra. I'm from, I was born in Mexico, but I have lived most of my life in the United States. I come from Washington, D.C. I have been an Android developer since 2010, since about the time my daughter was born, so I remember it very well. I recently, like 3 years ago, I transitioned to engineering management, and I work at Comcast, a company some of you might not be familiar with here in Europe, but you might know one of our sub companies, Sky, Universal, right? Like Jurassic Park, the Minion movie, that sort of thing, right? It's a large conglomerate. So I'm here to talk to you about embracing 16 kilobyte page sizes, which is a new change that is coming up in Android. I worked on at Comcast, but I worked on the Xfinity app, which is a large app that we use for our customers in the US, or broadband customers, and our cell phone customers. Right, so we have services there and cameras. I've been using the camera feature because I have like home security cameras at home, and we have a lot of cats and a daughter, and like to watch things. See how the cats are doing. Are they getting fed? Anyway. I'm not here to talk to you about the Xfinity app. I'm here to talk to you about 16 kilobyte page sizes. So I'm going to do a little overview. I'm going to let you know what page sizes are and why they matter. I'm going to help you figure out if you're going to be impacted by this change, right? I'm going to help you be able to make this change, align your binary to 16 kilobytes. I'll give you some tips about testing, resources, and then we'll wrap it up. So let's start with the background. Our problem coming up is that Android 15 introduces support for 16 kilobyte page sizes, and apps that rely on NDK libraries might experience crashes if you don't update. Right? You'll have to rebuild your apps, otherwise they might crash. And this feature is available since Android 15 became available, which was, I think, 2 weeks ago. Google did the release on Pixel devices. So you might all be wondering, what are pages and why do they matter, and why would it matter that suddenly they are possibly 16 kilobytes? Well, memory pages is, it's the fundamental unit of memory management in your system. It's a continuous block of memory, of virtual memory. And I like to think of pages as like an atom, right? It's the most fundamental particle. You might have molecules in your system. You might think like molecule, matter, and all of that. I think pages is just an atom, the most basic thing. Generally, they're consistent. On Android, they've been consistent 4 kilobytes forever. On Linux, there's like 2 megabytes. Windows has 4, 2. macOS, for instance, it used to be 4K because it's dealing with the Intel processors and that sort of thing. Since Apple Silicon, it is 16 kilobytes, so that I think that's one of the reasons why their Apple Silicon is so fast too. And on iOS, it's 16 kilobytes, right, on iPhones. Like I mentioned, Android has had a 4 kilobyte page size limit defined, right? Like you would see declarations in your header files. This comes from Linux hierarchy. So the benefit that we get if you go from 4 kilobytes to 16 kilobytes is that you will potentially improve the performance of your app quite a bit, depending on it. But it does have a drawback that we'll get to later on. Back in, I don't know how many of you remember this, back in 2013, Apple released their A7 series chips. This was the first chip they released with 64-bit support, but not very well advertised. It also was 16-bit compliant, 16 kilobyte compliant, because it used to be 4 kilobytes. Lots of developers had some minor issues with crashes, things that we are experiencing on Android nowadays. And just like Apple transitioned 11 years ago, now Android is transitioning in a similar way. And like I mentioned with the Apple Silicon, same with the A7 and A15, whatever processors Apple has. The 16 kilobyte page size is, I think, what really helps a lot with our performance. been talking a lot about what 16 kilobytes and 16 kilobytes, but you all might be wondering, what does that hold? I did some rough calculations. So if you have an empty class, each class is 16 bytes. You can have about 1,024. If you have an integer, it's 4 bytes, so 4,000 double, half of that. Even at the string hello might occupy around 400. You might only be able to fit 400 of them on 16 kilobytes of memory. I don't know. Many of you probably took some computer science classes, computer architecture. So you might remember this from your computer architecture classes. We have the hierarchy of memory, how you go from faster to slower, and how the CPU registers all the memory. They are very limited, but that memory is incredibly fast because the CPU can read it and write it so quickly. And as you go farther on, the hierarchy is slower and slower. As you can see, pages live technically on RAM, but it's it's out there. It's very far into the hierarchy. So to understand a page, you might be wondering how it is used. So it's a fundamental block of memory. It's written into memory, meaning RAM, right? So when you load your app, you're loading it from ROM, right? Or what we call nowadays NAND, your NAND chip. You install the app, you're reading it. It's now there. It goes into RAM and it gets put into pages, right? That's how it is. So it doesn't happen at once. It's just little chunks, and that's why you have pages, right? So you might have thousands and thousands of pages of 4 or 16 kilobyte. Many of you might be familiar with this concept of paging. I personally use a Mac, and I run Android Studio and Xcode a lot of the time, and I only have 32 gigs of RAM. I wish my company gave me 64. I'm loving for the next upgrade. But anyway, when I'm running, I have Android Studio running, I have Xcode running, and I have the simulator on iOS and the emulator on Android. I'm using a ton of RAM, right? So I only have 32 gigs. So you know what happens? The operating system will be offloading those pages of memory into the storage, meaning my what we used to call the hard drive, my SSD drive, and it's writing it there, right? So it's a slow process. This doesn't happen on our smartphones. That same concept doesn't happen. There's something similar. So all of the anything that's loaded into RAM, it's there. But if things that are not going to be used, what Android does is that it puts it in a place called CRAM, SetRAM, I guess how you guys would pronounce it in these areas. And it's basically just compressing the pages, using essentially a zip file, putting them into your RAM. And the factor of compression is really good, maybe 50%, maybe a lot more, right? So it can keep it in memory. So that's essentially the paging that might happen on a smartphone on Android. Another concept to learn is, we know what a page is, but where is this stored? Where would you find it? And there's page tables, and page tables basically just map the location of this. Is this in virtual memory? Is this in your RAM, or is this in your set RAM? Where is the location, right? It's just a lookup table. That's what it is, essentially a page table. So the CPU needs to do an operation. It will read it. It will go to the page table, do a walk of the page table. Where is this location? Where is this text? Where is this class and all of that? And it would point, right? There could be page faults if the data that is trying to find, it gets the address and it goes and it's not technically on RAM. It's on CRAM. It decompresses it. It's a slow process, right? Anyway, so page tables are on RAM, and a page fault is when it cannot find it in RAM and it has to go and decompress it. It's the diagram you see there. The CPU makes the request, does the page table lookup. Is it on RAM? Perfect. Quick fetch. If it's not there, it's gonna be slow because it has to go and uncompress it from RAM, fetch it, and it's gonna add latency, frame drops, that sort of thing. There's a little thing, and I know I'm going through a lot of concepts, so we'll transition soon to how you can fix it, but I think it's important to learn this background. So there's this thing called the TLB, Translation Look-Aside Buffer, and it's a specialized cache within your CPU. So if you have a Qualcomm chip on your phone or a Tensor chip, it has this thing. The TLB, Translation Look-Aside Buffer, will map recent virtual to physical address conversions. So it's essentially copying the lookup that the page table did, but into the hardware of your CPU, and it's very, very fast. It's very, very fast. It will, if the data is there, it'll be a instant lookup. But the challenge is that because this is a logical part of your CPU, it's limited, right? It's limited size and limited space. And the size is of how many items can it have, how many pages, right? Because it's that's what it has. So if there's a miss, it's a slow. If that data is not in the translation look-aside buffer, it has to go to the page table, and that can be slow. And here's the same diagram as before, but with the TLB, translation look-aside buffer, and you can see if it's there, perfect. If it's not in the TLB, then you have to do a page walk, page table lookup, and then you could fall into the CRAM issue that I mentioned before. So more challenging. So why page table matters, and why would the page table has can generate a lot of overhead on your system, because if you have multiple pages, that's just additional overhead, right? It's more data that you have there to account for those pages. So if you have more pages in your system, larger pages in your system, instead of 4 to 16, there's a lot less overhead in memory. TLB, like I mentioned, has a limited number of entries, so that's a problem too. Basically I'm trying to say that if you use larger page sizes, there's less data overhead that you have to have. Because, for instance, I made this diagram. So if you have 4 kilobyte pages, you will end up having 16 entries, right? 16 pages to store 64 kilobytes. But if you were to use 16 kilobyte page sizes, you will only have 4. So that's the overhead that I'm talking about. It just, you would keep a lot less data, potentially four times less data that you need to manage, right? Not you personally, but the CPU and other systems. I kept thinking about 4K sizes and 16, and I'm like, why are we only making the transition now? Why didn't we make it long ago? Why didn't we go with 64 kilobytes, 1 gigabyte page size? Some of you might know Linus Torvalds, very opinionated individual. I like him a lot. But he has some spicy takes. So I looked up through the news groups, and I found out he discussed page sizes quite a few years ago, 2009, and he said something like 4 kilobytes is not just the supported base page size, it's the only sane one. Bigger pages waste memory like mad on any normal load due to the fragmentation. And this was 2009, right? I remember then, I think I had a Mac with 8 gigabytes, and I felt like so powerful, like I felt I could put everything. And nowadays I have 32 gigabytes, and I feel I don't have enough, right? So things change. And he has a really strong point with the wasted memory, and we'll get to it soon. But yeah, 2009, lots of things changes, right? I looked it up. I think around this time, most computers had like 2 to 4 gigabytes of RAM. So, memory was a lot more constrained then. I think, new Samsung devices, Pixels, 12, 8 gigabytes of RAM. So we have a lot more nowadays. So here you might start getting hints of why I'm talking about. If you suddenly go from a system that only has 4 to 16, maybe there's some wastage there, and you might see it here, right? So anytime you write a new single byte, your app requires a new byte of memory, you can potentially open up a new page, right? Before, if you have it on a system that only uses 4 kilobytes, you will be using 4 kilobytes of memory, even if that's the only thing that you write on it. But if you move on to a system that supports 16 kilobytes of page sizes, you would be wasting a lot more, right? So the final concept I want to discuss with you all, as we will get into how to deal and how to make sure your app doesn't have any issues, is native code. I always think that I'm a native developer and I just write native code, meaning Kotlin or Java. But technically, if you're saying native code, you pretty much are saying C code or C++. So I'll be mentioning native code later on. So I'm just trying to get you all to understand. I personally use this. I use lots of native code. I have a personal app on the Play Store. and I do some audio analysis, and I have a C library, right? Because I have the same C library also run on the iOS app that I have, but also because it's so performant, right? It's so performant, still a little bit more performant than Kotlin and Java. So all of you might have wondered all this time why I have been talking so much about it. Why is this important? And it's because this will actually bring performance improvements to all of your apps, pretty much all of your apps. You will have a lot fewer page faults, faster memory access. The translation look aside buffer will have all those mappings, so things will be very fast. You might be wondering how much faster will things be. I do have some metrics for you. So this is on a Pixel 6. So there's page faults reductions like 4 times. How does that come into performance? Well, you will probably experience almost 1 second of faster boot times if you use native dependencies in your app. Google has some metrics, and for instance, the Google Search app is 17% faster app launch. Google News 30%. That's quite significant, right? Because I'm sure many of you do. Our product team and business team always want faster app launch, right? Faster getting the users into the app to engage. So you can get big gains. You'll use a little bit less power because there's a lot of less access CPU operations. And if you're a fan of benchmarks, you'll see gains between 2 to 10%. So potentially significant for you. So, going through the hassle of the things you need to make to make your app 16 kilobyte page size compliant is important. There is a con, a really, really big one. Your app is going to use around 9% more RAM. And that's because of what I was showing, right? Like pages won't be full, right? You might have a page with 2 kilobytes, 4 kilobytes. There will be wasted space in some of them. And recompilation will be needed. Your app will need to be recompiled to run properly on 16 kilobyte systems. So now we get to more exciting stuff. So we'll go to how to figure out if you're going to be impacted by this. Are you only using Kotlin or Java code? Are you only writing that? If you do, you probably don't have a lot to worry about. Kotlin and Java code run on the Android runtime. So this automatically will adapt to any page size, not just for 16, but if in the future we go to 32 kilobytes, 64 kilobytes, no problem. You're good to go. However, although you may be only writing Kotlin and Java code, that doesn't mean that your app does not have a dependency that includes native code, right? C code. So you are probably going to be impacted even if you don't write any C code yourselves. How would you figure out if your app has any native code? You can look up at your APK, and you would be looking for .so files. It means shared object. That's what it stands for, SO. So you would have to look up there and see if you have any. You can find them in the libs library folder of your Android APK. So you would find those files there. So I recommend you all to take a look. I'm sure, how many of you know the APK analyzer on Android Studio? Yep, I use it all the time. I love it. So please use it. You can use it easily to look at your APK. I pull up here Gmail APK, Android, the APK analyzer, and I'm going to the libraries folder there, and I can see that they have, I go to the ARM64 because that's what our devices run. And you can see the Gmail app has lots of libraries, SO libraries, native code, right? So that's how you can find it in yours. Okay, so we found that we have some dependencies in our app, right? Some shared objects. How would we know about knowing are these shared objects compatible or not with 16 kilobytes? Well, there's a script for it. And Google came up for the script. You can take a screenshot, but you can also find it on Google resources, right? I didn't write this. I did modify a different version because If you look at it, it will be printing different colors for things, right? It's just looking for ESO files in your in the folder you give it, and it will inspect the object alignment, the load segments. It's pretty much looking at the headers and seeing what it supports, and it will, let you know if it's 2 to the 14, which if you know math, you might not know this. I had to look it up in the calculator actually. 2 to the 14 is 4 kilobytes, 4096, and 2 to the 16 is, Anyway, so if you look at the script, it's going to show you different colors based on what you find, red, green, and blue. Didn't run on my Mac, on my terminal. I didn't see any colors. I just saw to skip characters. I did modify it a little bit in a different key. So you might have to do it, but it works. It just might not give you the colors that it says there. So anyway, you can run that script and it will let you know. And here's how I did it, right? I grabbed the APK from Gmail. I renamed it to zip because an APK is just a zip file. You can just rename it to that. I renamed it. I looked there, and because it's a split APK, it has multiple other APKs there. I look for the split APK of ARM v8, which is the libraries for your ARM processor in your phone. I found them. I renamed that again to zip because it's another APK. Okay, and then I look for the libraries there. I found them, so I dragged them all into another folder where I already had the script, right? The script that I showed before, the shell script. I dragged them there. And then I just ran the script. Running the script in my terminal. And the script gives you the result. And as you can see here, all of the libraries in that version of Gmail are not aligned. So anyway, I'm sorry. Do you have a can? Yeah, so somebody, I guess I'll take questions at the end, maybe. But yeah, that's a good one. Yeah, so I'm looking at an APK. The question was why would I be inspecting this and why would I find? Yes, because people have not supported 16 kilobytes before, so you would find the binary files there. So what I'm doing is just trying to see, are these files compatible? So that's why I run the script and I see the results that they are not, right? It shows me not aligned. So that's what I'm trying to do there. So where do the ESO files come from? ESO files, like I mentioned, is native code, right? It probably comes from third-party libraries you have. You have Firebase, Crashlytics, that sort of thing. You have native code in your app. So you're going to run into issues, right? You may also be impacted by transitive dependencies. So, you'll know, hopefully, transitive dependencies. I might be bringing this dependency, but that dependency is dependent on something else, and that might have shared native code, right? Shared objects. So that's a problem we have. So some of the examples are very common: Firebase, React Native, TensorFlow, OpenSSL, WebRTC. A lot. There's a lot. So those dependencies become part of your app, and then that causes your app to not be aligned with 16 kilobytes, right? So if you run that script that I mentioned on those libraries, it would fail, right? So a problem I had, especially at Comcast where I worked, is that we have a lot of internal and external libraries into our app, a lot, right? It's a large app. And I encountered some ESO files and I didn't know where they came from, because some of those ESO files were not called like firebase.so. It was something else, right? So had to do a little bit of digging. How could I find out who's bringing this to the app? So for that, at first I was literally looking for the name. Does this sound like Firebase? Does this sound like something else? Needless to say, that's not a good approach and not very helpful. And then I was running into issues that I would look at the name and I'm like, this sounds like a Jeff's problem. I'm like, Jeff, is this yours? I don't know, Chrystian. I don't know. So it wasn't a very scientific way to do it. So I asked a member of my team, Kyle Lehman, very smart person with all CI and all those things, and he's like, I'm not sure, but I'm gonna ask around. So I believe, not 100% sure. I think this actually comes from Jake Wharton, whom many of you are using his libraries. So anyway, Jake gave it to Kyle, and Kyle gave it to me, and I slightly modified it. So it's like a lot of people touch this. So this is a script. You probably want to take a picture of this one. It will help you a lot. It helped me a lot, right? So the script is will search for your your Gradle cache. It will look the entire Gradle cache. It will exclude all the documentation files because there's no value there. Then we'll unzip those files and output it into a .out file, right? A simple text file that you can look at. So what I did is I put it on my project, I ran it, and I found the source, right? So at first, like I mentioned, I was talking to Jeff, like, this sounds like you, and he's like, I'm not sure, because the name of the library was called libjingle. We didn't have any, library called that, so I found it. And as you can see there, it gives me the contents of, for instance, Google WebRTC dependency, shows me what is bringing into my APK, and I see there it's bringing libjingle. So it's WebRTC brings libjingle, so this helped me out, and hopefully it'll help you out. So we found out the source. How do we fix this, right? Now I know libjingle is a problem. How would I fix it? Well, for first-party dependencies, it's work you have to do, right? So if it's your library, you have to do it. You have to rebuild it. How do you rebuild it? It's a pretty easy process. I think you'll all be surprised how easy it is, but you do have to do a little bit of work, very little. You have to do 2 steps. One, you have to be using at least the Gradle plugin 8.5.1 or newer. Hopefully many of you are. We already are. I hope you are. It's hopefully an easy process for you. So anyway, update your Gradle plugin. Hopefully that's easy. And next, you have to update your build configuration of those libraries. So you essentially add a command to your CMake argument, where you tell it, essentially support flexible page sizes on. And this will work for 16 kilobytes, 4 kilobytes. So this will be backwards compatible with your 4 kilobyte, and it will also work on 16 kilobytes, right? You're just future proofing. A device comes with 64 kilobyte support, you're good to go. On other build systems, it might look slightly different, but it's pretty much the same thing, right? This is, if you're not using NDK build or CMake, you might have to add this, but it's the same, max page size and 16 kilobytes. You might be wondering, is this really that easy? And it is, right? So I looked up public repos with that. So Sentry Native, I think Sentry has a boot here, and that's their PR. I mean, that looks pretty simple to me. I mean, I could do that. Here's from one from Google Oboe, which is, I think it's a library for audio. One line. I mean, how easy is that? Seriously. So, just generic. If you happen to be writing C code, you just have to make some changes to the way you do things. If you're the one that is writing that C code that is getting written in libraries, all you really have to do is, instead of hard coding 4 kilobytes when you request page size or memory operations, just use the memory operations that request the available size, right? So that fixes all problems for you. Stop hard coding things, and you just write, the function to dynamically retrieve the correct page size. The problem is going to be the third-party dependencies, right? I told you how you can easily make that change, but you are dependent on other people. Like I mentioned, many major dependencies have that, and they already support it, right? A lot of dependencies have been releasing changes August, September, and even now, right? So WebRTC did it, AWS did it. I had to send them a couple of emails, but they did it. Firebase did it too. Most have done it, but some have not. Right? So you're gonna run into challenges. Many popular libraries are still not. Some of them like Realm, React Native. Well, many of us are not writing React Native code, but they don't support it. I know Flutter has a lot of issues too with that. Mapbox has some problems. And what happens if you haven't made your app compatible? A user launches the app on a 16 kilobyte only device, the app is gonna crash. Right? It might crash at app launch, or it might crash whenever you make reference to that. Right? So the app will be unusable. So anyway, so I showed you how you can make your app compatible. How would you be able to test this, right? So I have some good news and bad news there. So although Android 15 adds support for 16 kilobyte page sizes, no production device ships by default with 16 kilobyte page enable. Not by default, right? So if you have a Pixel 8 device, any of the Pixel 8 devices, the Pro, the the Lite version, I guess the A, and all of that, they have a new depth setting. You can go since a recent beta of Android 15, and now with the commercial release of Android 15, it has it a developer option, and it's boot with 16 kilobyte page size. So this is you can load it onto your device and run it. I don't yet have a Pixel 9. I don't know if they have it. I looked it up. A lot of people didn't seem to think it had it, but I guess it was like Reddit, so could be wrong. Could be wrong. Anyway, there's a challenge. You have to wipe. So if you want to enable that, you'll have to wipe your device, unlock your bootloader, and then anytime you switch modes, the phone restarts. I like to use Google Wallet. I like to use banking apps. That's probably not going to be available to you, right? So if you're doing it, you might want to do it on a test device. Many apps don't allow unlock bootloaders because they're concerned about security, banking, wallet, credit card, and all that stuff. And I get it. So that's a pain. You can also use the emulator. If you have an Intel system or x86, I guess I'm referring, or an ARM chip on your app, a Mac, you can download an emulator, and it will work just fine. I tested a lot with the emulator myself. So anyway, once you enable that toggle, if you still want an additional check, like am I really running the phone on 16 kilobytes, ADB has a command that you put it into the terminal and let you know, yeah, this phone is running in 16 kilobytes. You can also run a zip-align command with your final APK. Once you created the APK and you got all your dependencies updated, you can just run a zip-align. This won't tell you what dependency. This is not the same type of command that I showed you before of the script that lets you know each SO file and if it's aligned or not. What this will do is it will just tell you your APK in general is aligned or not. You'll need to do a lot of testing, right? But anyway, you may be wondering, like I mentioned, I kind of defeated my point of like, this should matter to you, but no device ships with 16 kilobyte by default. However, many users are using it already. I went on Reddit again. A lot of people, somebody opened this thread like, anybody booting with 16 kilobyte page sizes? Lots of Android enthusiasts that they see the toggle and turn it on. And a few people responded, and I love this response, right? From SVJNS. I just turned it on today, and basically all the apps that I care to test just crash, right? Again, like I mentioned, that's what will happen if you don't make some changes to your app. So anyway, even if you don't think a user is currently today, having a device that came to their house, they unpacked it, and it's not running on 16 kilobytes, the user could be making it run. So anyway, I want to share how the app that I worked on, Xfinity, what our experience was. Back in when Android 15 release notes came out, I looked at the release notes and I skimmed through them, to be honest. I skimmed through them and I looked at all the interesting stuff and I saw 16 kilobyte thing. It didn't ring a bell to me. And I went through the other stuff to make sure, our service is going to be impacted, all those things, right? Background, foreground services. Anyway, back in June, we started thinking we need to target Android 15 for our app, right? And we did a kickoff, and I took ownership of ensuring we had 16 kilobyte support, right? I ran the script, identified we had 9 dependencies that were incompatible. During July and August, we updated our internal dependencies. It was so easy, you know. It was so incredibly easy. And then August and September, it was me personally reaching out to like Amazon, AWS, like, I need your help. Here's the problem. Reach out. I open issues on some open source libraries, and it worked, right? It worked. As of October, our app is 16 kilobyte page size enable. I have a Pixel 8 dev device at home. I have been running it on 16 kilobytes. It runs super fast. It runs super well. I measure our startup time, right? App launch time. It's about 7% faster. I'm really excited about it. I wish more of our customers had enabled 16 kilobytes because it will boost our metrics, right? I wanna show and highlight like app startup for our users is better. Some of the key learnings we had is that testing took a lot of time to test. We had to make changes to libraries we don't often touch ourselves, right? So we were concerned about impact, right? So it took a lot of times. Anyway, here are some helpful resources for all of you. Google has amazing resources for them. I actually got in touch with Stephen Merchant at Google. He wrote a couple of those articles and they're phenomenal. If you want to delve deeper into this, you should definitely take a look. There's even a YouTube talk by some Android engineers about it, very much into the Linux side of things, but you might find it useful. Anyway, just in conclusion, I just want to show you this slide again. This is the Pixel 6. Things will be faster for your users for potentially very little work for you. So, making those changes hopefully matters for you and for your customers. So, it's pretty much you want a faster app launch and avoid the risk of your app crashing, you should update. And thank you. That's all for it. My name is Chrystian. You can find me. My name is spelled with a Y. That's why I repeated my name. It's spelled with a Y. It's slightly unusual. I have 2 last names. You can probably find me somewhere. You can probably even figure out my work email. But yeah, you can find me. LinkedIn, anywhere. I'm everywhere. So they don't have a handheld mic. So if you want to ask questions or something, you can just come over and we can discuss. But thank you very much.